Section 6.3, P21. We have the binomial distribution here, which sounds like we're starting to get pretty fancy, but it's really just a series of trials where each trial has a certain percentage of coming true, like flipping a coin 20 times, and each time you have a 0.5 chance of getting a heads, or rolling a dice 10 times, each time you have a 1/6 chance of getting a 3, for example. These are the binomial distribution at work. So we would have 40% have type A blood, and we need 2 donors. I'm actually going to do it real quick with a spreadsheet here to give you an idea of how we could get these answers and much more very quickly. I'm going to fill down to cell 14, click on this and fill series. What that'll do is just make each one go up by 1. So this is, probably should insert this. This is type A's. So this is the number of type A's that I get, and that's the probability that I'm looking for. So let me do a quick formula here. I'm just going to put equals and then binom, because I'm looking for the binomial distribution. I see that I'm given 3 options. I'm going to get that binomial distribution. And then notice that Excel will prompt me for what I need to input next. So here I need to get the number of successes. It says number of S, number of successes. In this case, that would be a type A. So I'm just going to this is the formula, the probability of getting 0 type A's, and we're going to move down from there. So whatever number is here will be my number of type A's. Number of total trials will be 13, because I'm having 13 selections from the random pool of people. The probability S, so the probability of a success is 0.4, since each person I draw will have a 40% chance of being type A. And then cumulative, this is a yes or no. Do I want a cumulative probability, or do I just want specifically for this number? And let me do it both ways and I'll show you the difference. So I'm going to put 0 here for not cumulative. I'm going to fill that down. So this is, maybe I'll put P not cumulative, and here P cumulative. Okay, I'm going to fill this across to do the same thing, but notice when I fill it across, it switches me now to B2, and I really wanted A2 still. The other difference is I do want to be cumulative here, so I'm going to change that 0 to a 1. Fill down. So what are the differences here? One, you can see that these numbers are much higher in the cumulative. You also notice that they end at 1. And the reason why is this is the probability of having this many type A's or less. So by the time you get up to here, this would be the probability of having 13 or less type A's. Well, that's going to be 100%, because we can't get more than 13 type A's if we're only drawing 13 people. Whereas this is the probability of getting a specifically that amount. So this would be specifically the probability of getting exactly 2 type A's out of our 13 people that we're drawing from the population. Okay, so this is cumulative, this number or less. These probabilities just give you the probability of getting this number of A's. So the first question, what's the probability that we get 0 or 1 donor with type A? So I could either add these 2 numbers, or I could just use the cumulative up to 1 to give me 0.0126. And will it be certain to find at least 2 donors? Well, one way I could do that is I could sum these, because these are the individual chances of getting 2, 3, 4, 5. So I could sum these up and I get my 0.9874. Or I could notice that this, the chances of getting 0 or 1, and this, the chances of getting 2 through 13, must add up to 1, because the total probability must always add up to 1. So I could take 1 minus these two, so minus this number I got in the first part, and 1 minus that would give me the probability of all of these combined. So two ways to look at that one there. Would it be almost certain of finding at least 2? Yes, because we'd have almost a 99% chance in this sample of 13 donors.